going to learn about whole numbers. First, before that, we all know that what are natural numbers. The counting numbers are called natural numbers. The numbers start from 1, 2, 3, 4, 5, 6 and so on. So, what about whole numbers? All natural numbers with 0 are called whole numbers. Okay. Then, next predecessor, successor. What is successor? Adding 1 to the number gives the next number, that is the successor. For example, the successor of 13 is, so I told you we have to add 1. So 13 plus 1, 14 is the successor of 13. Okay. Adding 1 to the number gives the next number, that is the successor. Okay. For example, the successor of 26. I told you we have to add 1. 26 plus 1, 27. What is the successor of 7? 7 is 8. What is the successor of 3? That is 4. So, we have to add 1 to the number. So, we will get the next number. So, what are the predecessors? Predecessors are subtracting 1 from the number gives the previous number, that is called predecessor. For example, the predecessor of 13. I told you we have to subtract 1. So, 12. Okay, 12. Next, what is the predecessor of 26? That is 25. What is the predecessor of 4? That is 3. We have to subtract 1 from the number gives the previous number. So, what are the predecessor and successor of 2? 2. Here I told you successor means we have to add 1. So 3. This is successor. What is the predecessor? So we have to subtract 1. So 2 minus 1, 1. 1 is the predecessor. Okay. Next. What are the predecessor and successor of 1 in the case of natural numbers? Here 1. What is the successor? I told you we have to add 1. So, the successor is 2. Here, in the case of natural numbers, there is no predecessor for 1. But in the case of whole number, see 1. In the case of whole number, the successor is 2 and the predecessor is 0. In the case of whole number, this is predecessor and successor is 2. Next, number line. Number line means 0, 1, 2, 3, 4, 5, 6. What are 0, 1, 2, 3 are whole numbers. We made a number line for this whole numbers. Okay. Here 0 to 1. This is the unit distance. Unit distance. This unit distance we have to mark the same unit distance for all. Same unit distance for all. If we want to extend, we can extend it also. Okay, this is a number line. We made a number line for whole numbers. This is the unit distance. We have to mark the unit distance for all. Same unit distance for all. Okay, next. Now we are going to add on number line. 3 plus 4 on number line. First, we have to go to the place 3. Okay, 3. We have to add. Add means we have to go to the right side. When we are adding, we have to go to the right side. How much jump I have to jump? 4 jump. Otherwise, 4 moves. 1 move, 2 move, 3 move, 4 moves. So, what is the answer? 3 plus 4 equal to 7. Understood? Next, one more. 2 plus 6 on number line. I told you we have to go to 6. We have to move 6 times. 1, 2, 3, 4, 5, 6 times we have to move. So, what is the answer? 8. Okay. Next. 4 plus 5 on number line. Here, first I told you we have to go to 4. We have to move 5 times. 1, 2, 3, 4, 5 times. So, 4 plus 5 equal to 9. Understood? This is the method of adding. Next, coming to subtraction on number line. How to subtract on number line? Here I told you, when we are adding, we have to go to right side. When we are subtracting, we have to go to left side. Understood? When we are adding, we have to go to right side. When we are subtracting a number, we have to go to left side. I told you we have to go to this place 7. So how subtraction? So we have to go to left side. How many moves? 5 moves to left. So 1, 2, 3, 4, 5. So 7 minus 5 equal to 2. Okay. One more. 9 minus 2 on number line. I told you subtraction we have to move to left side. We have to move to left side. First starting from 9, I have to move 2 times. 1, 2. What is the answer? 7. 9 minus 2 equal to 7. 7 is the answer. Next, coming to multiplication on number line. How to multiple 4 into 3 on number line. Here we have to jump 4 jump. We have to jump 3 units. Okay. Each jump we have to move to 3 units. Listen here. 1 unit, 2 unit, 3 unit. Okay. So how many jump? 4 jump to 3 unit. 1. Okay. Here it is not sufficient. I will add. Okay. 1 jump I have jumped. So next 3 unit I have to jump. Okay. 1, 2, 3 unit. Again third jump. 1, 2, 3. Then 1, 2, 3 again. So we have to jump 4 times. 4 jump. Each jump will have 3 units. So answer is 12. 4 into 3 equal to 12. I will do one more. Listen here. I have to jump. 2 jump I have to jump to 4 units. 1, 2, 3, 4 units. So 2 jump from starting from 0. 1 jump, 2 jump. Each jump will have 4 units. Okay. So 2 into 4 equal to 8. Next one. 3 into 3. I told you we have to jump 3 times to 3 units. So starting from 0, 1, 2, 3 jump to 3 units. So 3 into 3 equal to 9. Next, properties of whole numbers. There are 4 properties are there. Closure property, commutative property, associative property, distributive property. Each property we have to go under addition, multiplication, subtraction and division. Okay, let us see one by one. Here closure property under addition. Closure property means when we are adding two whole numbers, we get a whole number. See, 2 plus 2. 2 is a whole number, 2 is a whole number. We get a whole number. So the sum of any two whole number is a whole number. Here 3, 4 and all whole number. When we are adding two whole number, we get a whole number. So the whole numbers are closed under addition. Okay. Next, closure property under multiplications. When we are multiplying two whole number, we get a whole number. The product is also a whole number. So when we are multiplying a two whole number, the product will also be a whole number. Any number, 3 into 8, 24 is a whole number. So the product of any two whole number is a whole number. So these whole numbers are closed under multiplication. Next, closure property under subtraction. When we are subtracting 7 minus 5, we get a whole number. But in the case of 5 minus 10, we get minus 5. Minus 5 is a integer. That is not a whole number. So when we are subtracting the two whole number is not always. That's why I written always. Here whole number is coming. Here the whole number is not coming. This is an integer. So is not always a whole number. So we can conclude that whole numbers are not closed under subtraction. Okay. Next coming to division. For example, 5 divided by 5. How I will write 5 by 5 equal to 1. When we are dividing two whole number, I am getting here whole number also. But in the case of 2 divided by 10, 2 by 10, so 1 by 5. This is a fraction. This is not a whole number. Okay, so division of any two whole number is not always, that is not always a whole number. So we conclude that whole numbers are not closed under division. So conclusion, the closure property, addition and multiplication are possible, subtraction and division are not possible. Okay. Next coming to commutative property. Commutative property under addition. When we add the whole number in any order, for example 7 plus 2, I am changing the order 2 plus 7. 7 plus 2, 9. So 2 plus 7 also 9. Okay, same. 3 plus 2, 5. I am changing the order 2 plus 3, 5. So it will not affect the answer. 5, 5. So when we add the whole number in any order, we get the same answer. So we conclude that the whole numbers are commutative under addition. Next, commutative property under subtraction. See, 7 minus 2, 5. Here 2 minus 7, minus 5. Here minus 5 is an integer. We are not getting the whole number. Okay, 3 minus 2, 1. 2 minus 3, minus 1. So when we subtract the whole number in any order, we are not getting it. So we conclude that the whole numbers are not commutative under subtraction. Next, coming to multiplication. Here multiplying 4 into 5. So 20. 5 into 4, 20. Here 8 into 3, 24. 3 into 8, 24. When we are multiplying the whole numbers in any order, like 4 into 5 or 5 into 4, 8 into 3 or 3 into 8, we get the same answer. So the whole numbers are commutative under multiplication. What about division? Here in division, for example, I am writing 5 divided by 10 equal to 10 divided by 5. I am changing the order. So 5 by 10 equal to 1 by 2. Here 10 by 5 equal to 2. Here 1 by 2, here 2. So we conclude that whole numbers are not commutative under division. So it is possible only in addition. And next coming to associative property. Associative property means when we are adding, see here, A, for example, A plus B plus C equal to A plus B plus C. When we are adding three numbers, if they grouped in a different way, it should be equal. So here 2 plus 5 plus 3. Here 2 plus 5 plus 3 means 8. Next 2 plus 5, 7. 7 plus 3, 8. 10. Here 10. We are grouped in a different way. Here I am grouping 5 and 3. Here I am grouping 2 and 5. In grouping in different way, but it will be equal. So the whole numbers are associative under addition. Understood? When we are grouping in different way, we should get the correct answer. That should be same. Here 4 plus 2 plus 5, 7. Here 4 plus 2, 6 plus 5. So 11, here 11. When we are grouping in different way, it should be same. So the whole numbers are associative under addition. Next coming to multiplication. Associative property on multiplication. Here also 2. I am grouping this 5 into 3. So what is the answer? 2 into 5 into 3, 15. Here 2 into 5, 10 into 3. 10 into 3. So 2 into 15, 30. 30. So the product of 3 or more numbers does not change if they grouped in a different way. 30, 30. Here I am grouping this 4 into 2 into 5. So 4 into 5 2s are 10. Here 4 2s are 8 into 5. So 4 10 40, 8 5s are 40. So the answer is same. So the whole numbers are associative under multiplication. Next, subtraction. Here 7 minus 5 minus 3, 2. Here 7 minus 5, 2 minus 3. So 7 minus 2 equal to 5. Here 2 minus 5 equal to minus 1. So here, 1 minute. Here 5, here minus 2. There is a variation. If we are grouping in different way, we are not getting the correct one. So the whole numbers are not associative under subtraction. Understood? Shall we do one more? 9 minus 4 minus 3, 1. Okay. Here 9 minus 4, 5 minus 3. So 9 minus 1, 8. 5 minus 3, 2. Okay. 9 minus 1, 8. 5 minus 3, 1. So when we are grouping in different way, we are not getting the answer. So the whole numbers are not associative under subtraction. Coming to the division. So when we are, for example, 5 divided by 10 divided by 2 equal to, we are grouping this divided by 2. So 5 divided by 10 divided by 5. 5 divided by 5 by 5 equal to 1. Here 5 divided by 10 divided by 2. 5 by 10. 5 by 10 as 1 by 2. Divide by 2. Here 1 by 2 multiple. When we have to change to multiple, we have 2 by, it becomes 2 by 1 becomes 1 by 2. Okay. So 1 by 4 is the answer. So here 1, 1 by 4. When we are grouping in different way, we are not getting the same. So the whole numbers are not associative under division. Next, coming to distributive property of multiplication over addition. Here 2 into 5 plus 3. 2 into 5 plus 3. Here we have to distribute. This 2 is distribute to this number. 2 is distribute to this number. So how to write 2 into 5? Here plus, you have to write plus here 2 into 3. I am distributing this 2 to here also. Okay. So 10 plus 6. The answer is 16. Here 4 multiple by 3 plus 5. Here 4 I am distributing to 3 and also to 5. So how to write 4 into 3? Here plus 4 into 5. So 4 3s are 12 plus 4 into 5, 12. So answer is 32. Okay. Next, coming to distributive property of multiplication over subtraction. Same like addition only. We are distributing this, we are distributing this. Here minus sign only. 4 into 5 minus 4 into 3. So 4 3s are 20 minus 12. The answer is 8. This is the distributive property. Shall we do one sum? Find 15 into 68. So here before that 15. Shall we write 10 plus 5 into 68 as 60 plus 8. Using the distributive property, here I am 10 into here. Here I am multiplying this. Okay. So 10, okay, into 60 plus 8. Here plus. So here plus 5 into 60 plus 8. Understood? So here using the distributive property, here 10 into 60 plus 10 into 8. Okay. Plus 5 into 60 plus 5 into 8. 5 into 60 plus 5 into 8. So here 600 plus 80 plus 300 plus 8 5s are 40. So total 1020. Easy calculation using the property. Okay. Next, identity of addition of whole numbers. Here 0 is the identity element of addition of whole numbers. When we add 0 to any whole number, the result will be the same number. For example, 5 plus 0 equal to 5. 15 plus 0 equal to 15. 38 plus 0 equal to 38. So 0 is the identity element of addition of whole numbers. When we add 0 to any whole number, the result will be the same number. Okay, next coming to identity for multiplication of whole numbers. Here 1 is the identity element of multiplication of whole number. When we multiple 1 with any whole number, the result will be the same number. For example, 24 into 1, 24. 78 into 1 equal to 78. So 1 is the identity element of multiplication of whole number. Next, patterns in whole number. Calculation can be simplified by observing pattern. So 9 can be written as 10 minus 1. So 99 can be written as 100 minus 1. 999 can be written as 1000 minus 1. 9999 10,000 minus 1. Next 5 can be written as 10 by 2. 25 can be written as 100 by 4. 125 can be written as 1000 by 8. Just you remember this. Okay. Next, multiplication or addition of 99, so on. First, 64 plus 9. So, 64 I told you 9 can be written as 10 minus 1. So, here 64 plus 10, 74 minus 1, answer is 73. Here 4 into 99. 99 can be written as 100 minus 1. Using distributive property. Using distributive property of multiplication over subtraction. Here 4 into 100. I am distributing 4. So 4 into 100 minus 4 into 1. So 400 minus 4, the answer is 396. Here multiplication by 5, 25, 125. So when we are multiplying, I told you 5 can be written as 10 by 2. 125 can be written as 1000 by 8. Okay, here 48. 5 can be written as 10 by 2. So here 2 1 times, here 24 times. So the answer is 240. Easy calculation. 16 into 125 can be written as 1000 by 8. Okay. So 8 1 times, 8 2s are 16. So the answer is 2000. Okay. Here multiplication by 15 and 35. So 12 into 15 can be written as 30 by 2. Shall we write like this? 2 into 1 times 6 2s are 12. So the answer is 180. Here 8 into 35. 35 can be written as 70 by 2. So 70 by 2. 2 1 times 4 times. So 280. Okay.